All right, hello everyone, and welcome back. Today we are going to be looking at vector operations. Operations are adding, subtracting, and scaling, not necessarily multiplying. We are actually not going to get into multiplying vectors this year. We do usually talk about multiplying vectors, but we do not have time to go over that this year. It is a bit strange, and the concept of multiplying vectors is not what you would think. So when we are going to be doing multiplying, we're going to be scaling, meaning we're taking a vector and we're just like doubling it or tripling it or something like that. We're not exactly going to be multiplying a vector times another vector. That is for another class for you guys. So let's get into it. Okay, so we're going to get kind of visual today. So those of you who are more visual learners, I think today will hopefully help a little bit with visualizing what we mean when we're adding and subtracting and scaling vectors. But the first most important thing that you have to remember when you're doing any kind of operations with vectors, you can only perform these operations on vectors that are in component form. If you don't know how to put a vector in component form, you need to go watch the last video. All right, so that is number one, the most important rule. You can't add vectors that don't have the same kind of initial point. You need that starting at 0, 0 in order to kind of do these operations. All right, with that being said, we're going to get into what it looks like to add, subtract, and then scale a vector. So I kind of have these little arrows kind of set out here because I'm going to be using them to show you guys what this is going to look like. All right, so when you're adding vectors, right, so you can take, so we have vector A, B, and then we have negative B. We're going to just look at vectors A and B. So if we wanted to add vectors A and B, all right, we're going to do that first. So first we're going to do this visually. So if I want to add A plus B, all right, what I'm going to do is I'm going to take my A vector, all right, so I'm kind of just like stealing it. Come here. All right, and I'm going to put that kind of, first. So remember, we're at, so initial points, all right, 0, 0. All right, so here's my vector A. All right, so I took A. A is in component form, right? So we know that A starts at 0, 0. So then if I want to add B to it, I'm going to go to the end of vector A, and I'm going to, oh, come on. Well, I'm going to try my best to get it at the very kind of like tip of vector A. Where did I just put that? So here is vector B. All right, now the addition vector, so that's what it looks like visually. So you have A, you stick B at the end of it. So tail to head to tail, or whatever you want to think of it. But the actual addition vector is the vector that goes from 0, 0, oops, that is not straight, to the end of vector B. So this is the addition vector. That is vector A plus B. All right, so that's what we're doing visually. So you're taking A and then you're stacking B on top of it, and then the addition is the connected from the start of A to the end of wherever B is. And this is a very important operation. We're going to use this a lot when we do our word problems. And you're going to see things like a plane traveling, due east. But then it encounters a wind with, whatever velocity. What is the result going to be? And this actually is going to be an addition of two vectors, because you have the vector that represents the plane's speed and direction, and then you're going to have a second vector that represents the wind's speed and direction. And so your actual plane's speed and direction is a combination of the two pieces, and that's going to be something that we do with addition. So this is kind of your visualization for those two pieces. So A plus B, you take A and then you stick B on the end. Now you might be wondering, does order matter? Could you do B plus A and it be the same thing? The answer is yes. B plus A is exactly the same length as A plus B, and I'm going to show you right now. All right, so I'm going to leave A plus B exactly where it is, and I'm just going to move these two vectors, and then I'm just going to delete, delete. All right, so now we'll start with B first. All right, so let's do B plus A and see if it's the same thing. All right, so we're taking B, so remember B was the purple one, and we're going to put that at 0, 0. As close as I can get to 0, 0. Come on. There we go. That's the best I could do. And then we'll stack A, which is a blue one, right on the end. Come on. Come on. Well, it's a bit it's a bit messed up because I can't get it to go like exact. Here, can I move you up? Nope. Okay. Well, anyways, it won't go exactly where I want it to. But if you look at it, you get the idea, right? Look, I put B first and then I stacked A on top of it, and it's the exact same A plus B. I did not move A plus B. A plus B stayed in the exact same spot. All right, all I did was switch the order and do B first and then A. And as you see, you get the exact same A plus B vector, which I think is kind of cool. All right, so it does not matter the order in which you add your vectors. You will get the exact same vector as the result. All right, and you can see if you look at that pink vector, it didn't change its degree, it didn't change its magnitude. It is literally the exact same vector in the exact same spot. Okay. Now, subtracting vectors. Now, technically, we don't have subtraction. We have adding the negative vector. So I'm going to go ahead, I'm going to put A and B kind of back. So here's B, here's A, right? Okay. So subtracting, before we get to subtracting, I didn't even give you guys like the you visually can see what adding does, but I didn't actually tell you like what you're doing. So hold on. So if you want to add, so let's say, I didn't even give these coordinates. What was I thinking? All right, so we'll say that A is x1 comma x2, and we'll say that B is x2 comma y2. All right, so then A plus B, so A plus B equals, you literally just add the x's and then add the y's. So x1 plus x2, comma, why does this one have 2? Did I just write my y really ugly? Who even knows? You just add the x's and then you add the y's. So this would be y2 plus y1. What in the world am I doing? There we go. So sorry. I don't even know what's happening. Plus y2. All right, so that's what you do. So you just add your x's, add your y's. That's the addition of the two vectors. All right, so moving on to subtraction. All right, so hold on. Before we move any further, let's go ahead and we'll label B. So if positive B is x2 comma y2, then negative B is just negative x2 comma negative y2. You make them negative. All right, so like I said, instead of really having subtraction, we have adding the negative vector. So it would be like this, right? So you would say A plus negative B. And negative B is just the vector. It's exactly the same length. It's just pointing in the opposite direction. All right, so if you were to look, so both of these are the exact same, they're the exact same length. And they're going in the exact same direction. So they like go over top of each other, right? You can see that they literally lay right on top. So they're the exact same vector. They just are pointing in a different direction. So their component form is exactly the same. It's just pointing in the reverse. So yeah. So think of it, if you're thinking of it like slope, B would have like, you know, a positive slope, whereas negative B would have like a negative slope, but the number itself is exactly the same. I don't know if that helps or not, but they're the same vector, they just point in different directions. So we would add the negative vector. All right, and if you wanted to do this visually, it's kind of the same concept, right? We just talked about what addition looks like. So it's still now addition, all right? So it's not like we did anything weird. It's just we're adding the negative or the reverse of the vector. So we'll do this. So A plus negative B. Where's my little arrow? There we go. So here's vector A. We'll try and get this at 0, 0. We're doing the best we can. Okay, that's as good as it's going to get. I don't know why it doesn't want to go exactly at 0, 0. It's giving me a hard time. And then we're going to take, instead of positive B, we're subtracting. So we're going to take negative B. And I'm going to move all of this. Nope, it doesn't want to. It doesn't want to. Here we go. We'll try again. We moved it. We ran out of space. All right, there we go. I'm just kind of throwing it down there as close as I can get at this point. All right, so this is vector A. This is vector negative B. All right, and so connecting, just like we did before, this is going to be A plus negative B. Now, this is not the same as vector A plus B, right? If you look at A plus B, all right, if I were to pick this up and move it, you obviously can see that that's not the same as that black line, all right, because we did go in the opposite direction with B. All right, so this is your subtracting vectors. This is what it would look like. All right, now this cannot go in the other order, just like normal subtraction can't reverse the order. All right, it's not going to end up being the same thing. So keep that in mind. Subtracting, just like all subtracting, has a specific order that it has to go in. It is not commutative, meaning you can't reverse the order and have it be the same thing. Okay, so if you're doing the points, right, so this would be, so I did this in black, so A plus negative B would just be, so for this one, it would be x1 plus negative x2, comma, y1 plus negative y2. Oops, you can't see because my head is in the way. Right, but you're just subtracting. So you're subtracting your x's. So even though there is no, technically we don't say that we subtract, we just add the negative. That's because there isn't a visual for subtraction, right? How do you have a vector and then take away some? So what we kind of think of it instead is, instead of having a vector and taking away some, we just say we're going to add kind of the negative vector. And the negative vector is just when you change the sign of the points. So if it was, you know, negative 3 comma 2, it would be positive 3 comma negative 2. That's your negative vector. All right, it's just you change the sign. Okay, so that is adding and subtracting. Last but not least is scaling. So this is when you take a vector and you multiply it by a number. All right, so remember, we're not multiplying vectors. This is just scaling. So we're either doubling or tripling a vector. All right, so scaling, like I said, this is, so remember, not multiplying two vectors, not multiplying two vectors. A vector by another vector. We are multiplying a vector by some constant. Okay, so that is important to remember. So we're not going to be multiplying a vector by another vector. We're multiplying one vector by some constant. All right, so for instance, if we wanted 2 times vector A, we would go take vector A, which is this blue one. So I'm going to steal it from here really quick. All right, and we would copy it and just stack another A right on the end. And I know that just going through all the words right now, but it was a big vector. I probably should have done this with B. In hindsight, you know, it's 2020, but I chose to do this with vector A and now it's big. All right, so this is vector A, this is vector A, so this whole thing is 2A, right? You could even do like this vector is 2A, right? Because it is the length of 2 A's. That's really all it is. So that's scaling a vector. So if we're doing this kind of in notation, 2 times A would equal 2 times x1, comma, 2 times y1. You just multiply both the x and the y by some constant number. In this case, it was a 2. Okay, those are our 3 operations that we're going to learn. And now what we're going to do is do some examples. All right, and each one of these is given to you in a different formatting. So number 1, it's given to us already in component form. Number 2, it's giving it to us using a magnitude and a direction. So we're going to have to put this in component form before we can go any further. And then the third one is giving us just the coordinates, and we're gonna have to put it into component form and then perform the operation. All right, so these are just one of each kind of type that you're gonna see. So for the first one, since we're already in component form, all right, we just need to kind of do what it tells us. So it says, find negative u plus 6g. So first off, I know I kind of skipped the instructions. We shouldn't skip our instructions. It says find the component form of the resultant vector. Resultant is just a fancy word for the result vector. All right, so this just means the result, right, of performing the operation. So resultant vector does mean kind of like what you think it means. So the resultant vector is just find the result of whatever operations it wants you to perform. All right, so I know it's kind of a fancy word, but it's used a lot in vectors. Okay, so here we go. We're going to do negative u. Now you can either do this in pieces or you can do this all at once. Because it's our first one, I'm going to do it in pieces and then we'll kind of put it all together at the end. I'm sure some of you are probably just going to want to do this all at once, but I'm going to, like I said, do it in pieces. So here we go, negative u. So it's negative, -8, and then negative, -4, right? So we're multiplying, we're getting that negative vector. So this is going to be 8, 4. All right, so that's negative u. All right, 6g is 6 times 7, 6 times 1. Oh my, 42. I was like, what is 6 times 7, 6? All right, and what we want is negative u plus 6g. So we want 8, 4 plus 42, 6. All right, and this is going to give us 50 and 10. So that is our resultant vector, 50, 10. All right, and that's it. All right, so it's pretty kind of basic math. All right, so just be careful where you put your negatives. That's kind of the main thing, right? Make sure you're adding the right parts. But other than that, I think you should have a pretty okay time. All right, so angle F, vector F. So first off, we need to put this into component form. So this is, F is going to equal 21 cosine 60, 21 sine of 60. Vector B is 10 cosine 30, 10 sine 30. All right, so we are now in component form. So what we want to do next is find our resultant vector. So we want to find negative 6f. So this is going to be negative 6 times 21 cosine 60, negative 6 times 21 sine of 60. Now I'm going to go ahead and simplify. So cosine of 60, so negative 6 times 21, and you could do that in a calculator too. I'm going to actually do that. Negative 6 times 21 is negative 126. All right, so this is negative 126. Cosine of 60 is 1/2. All right, and then this is also negative 126. Sine of 60 is √3/2. All right, so one more time, just simplifying, because I can times that by 0.5, and that's going to give me negative 63. So negative 63 comma negative 63 square root 3. So that's negative 6f. All right. Oh, unfortunately, I did give it a bad one for this one because 5. Oh no, it'll end up being fine. All right. So then we have yeah, let's change this to plus and negative, right? Because we want to add the negative. So this is going to be negative 5b equals, all right, and so that's going to be negative 5 times 10 cosine 30, negative 5 times 10 sine of 30. All right, simplifying, this is going to be negative 50 cosine 30, which we know the cosine of 30 also, so might as well just plug it in. Cosine of 30 is √3/2. Negative 50, sine of 30 is 1/2. So simplifying this all the way is going to give us negative 25 square root of 3, comma, negative 25. All right, so last but not least, we're going to combine, oops, you guys can't see that. I just looked up and realized that it wasn't in the right place. All right, so adding these two vectors together, so I have negative 6f plus my negative 5b is going to equal negative 63 minus 25 √3, comma, negative 63 square root of 3 minus 25. And you can't combine these because they're not like terms, right? So we can't combine the negative 63 with the negative 25 √3 because they're not like terms. So this is actually just going to be our answer. This is just how we would leave it. I know it's disgusting, but to me, it actually looks better than decimals. I know some of you probably really just want to turn this into a decimal, but we don't need to. There's no reason to turn this into a decimal. This looks much nicer and I don't have to do rounding. So ultimately, it's easier. All right, last but not least is problem number 3. Actually, I feel like you guys get the idea. So I think I'm just going to stop the video here. We're already at 23 minutes, and I think